main disconnect is required at a subpanel which contains more than 6 circuit breakers located within the same building and is not part of the service equipment. This requirement is rooted in the National Electrical Code, specifically Article 408.36, which addresses overcurrent protection for panel boards. A panel board is defined as a component designed to house overcurrent devices, such as fuses or circuit breakers, and is assembled in the form of a single panel. A subpanel, being a panel board fed from another panel board or service equipment, falls under these regulations. The primary reason for mandating a main disconnect in a subpanel with more than 6 circuit breakers is to provide a readily accessible means of disconnecting all ungrounded conductors simultaneously. This ensures electrical safety during maintenance, repairs, or in emergency situations. The NEC specifies that any panel board containing more than 6 overcurrent devices must have a main overcurrent protective device. This rule stems from the practical limitation of operating more than 6 individual circuit breakers quickly and efficiently in an emergency. Imagine a scenario where a fault condition arises within the subpanel. If there is no main disconnect, personnel would have to individually switch off each of the 6 or more breakers, which is time-consuming and potentially dangerous. A single main disconnect allows for a swift and complete shutdown of the subpanel's power supply. The 6 disconnect rule originated from early electrical practices where individual fuses controlled branch circuits. It was deemed manageable to manually remove up to 6 fuses to de-energize a panel board. However, with the advent of multi-pole circuit breakers and increased circuit densities, the need for a more streamlined disconnection method became apparent. Article 408.36 addresses this by requiring a main breaker or a set of fuses rated to protect the panel board's busbars and all the connected circuits. There are exceptions to this rule. Firstly, if the subpanel is used as service equipment, the requirements for service equipment disconnects apply, which might differ based on local regulations and the size of the installation. Secondly, certain industrial installations might have specific engineering designs that provide alternative means of disconnection, as long as they meet the overall safety objectives of the NEC. The requirement for a main disconnect also considers the accessibility of the disconnect. The NEC mandates that the disconnect be readily accessible, meaning it should be located so that it can be reached quickly and without obstruction. This ensures that in an emergency, anyone can easily shut down the subpanel. The rating of the main disconnect is crucial. It must be appropriately sized to handle the total load connected to the subpanel, as well as protect the panel board's busbars from overcurrent conditions. The ampacity of the busbars is a key factor in determining the required rating of the main disconnect. The busbars must be protected against overloads and short circuits. The installation of the main disconnect must comply with NEC Article 240, which governs overcurrent protection. This article outlines the requirements for the selection and installation of overcurrent devices, including circuit breakers and fuses. It specifies how to determine the appropriate ampacity of conductors, the interrupting rating of overcurrent devices, and the coordination of overcurrent protection. In selecting a main disconnect, it is important to consider the available fault current at the subpanel location. The interrupting rating of the disconnect must be sufficient to safely interrupt the maximum fault current that could occur. If the interrupting rating is too low, the disconnect could fail during a fault, potentially leading to a dangerous arc flash or equipment damage. The physical installation of the subpanel and its disconnect must also adhere to NEC guidelines. The panel board must be securely mounted and properly grounded. Grounding is critical for safety, as it provides a low impedance path for fault current to return to the source, allowing the overcurrent device to trip and clear the fault. The grounding system must comply with NEC Article 250, which covers grounding and bonding. This article specifies the requirements for grounding electrodes, grounding conductors, and bonding of metal enclosures. The subpanel enclosure must be bonded to the grounding system to ensure that it is at the same potential as the earth. This minimizes the risk of electric shock. Wiring within the subpanel must be neatly organized and properly supported. Conductors must be sized according to their ampacity, as specified in NEC Table 310.16, and must be protected from physical damage. The panel board must be clearly labeled to indicate the circuits it serves and the rating of the main disconnect. Proper labeling helps prevent confusion and ensures that personnel can quickly identify and operate the correct disconnect in an emergency. Regular inspection and maintenance of the subpanel and its disconnect are essential for ensuring continued safety and reliability. The panel board should be checked for signs of corrosion, loose connections, or damaged components. Circuit breakers should be tested periodically to verify that they are functioning properly. Infrared scanning can be used to detect hot spots, which could indicate loose connections or overloaded circuits. If any problems are found, they should be addressed promptly by a qualified electrician. In summary, the requirement for a main disconnect at a subpanel with more than 6 circuit breakers is a critical safety measure designed to protect personnel and equipment. Compliance with NEC Article 408.36 and related articles is essential for ensuring a safe and reliable electrical installation. The selection, installation, and maintenance of the main disconnect must be performed by qualified individuals who are familiar with the NEC and local electrical codes. The disconnect must be readily accessible. This means it should be located so that it can be reached quickly and without obstruction. The NEC specifies that the working space around electrical equipment operating at 600 volts or less to ground must be at least 3 feet deep, 30 inches wide, and 6 feet 6 inches high. This working space provides sufficient room for personnel to safely operate and maintain the equipment. The subpanel should not be located in a damp or wet location unless it is specifically designed for such environments. Moisture can cause corrosion and electrical faults, increasing the risk of shock and equipment damage. If the subpanel must be located in a damp or wet location, it should be installed in a weatherproof enclosure. The subpanel should be protected from physical damage. It should not be located in an area where it could be easily struck by vehicles or other equipment. If the subpanel is located in a high-traffic area, it should be protected by bollards or other barriers. The subpanel should be properly ventilated to prevent overheating. Overheating can damage the components of the panel board and reduce its lifespan. The panel board should be located in a well-ventilated area or should be equipped with a fan to provide additional cooling. The subpanel should be clearly labeled to indicate its purpose and the circuits it serves. Proper labeling helps prevent confusion and ensures that personnel can quickly identify and operate the correct disconnect in an emergency. The labeling should be durable and easy to read. The subpanel should be inspected regularly for signs of damage or wear. The inspection should include checking for loose connections, corrosion, and overheating. Any problems that are found should be corrected promptly by a qualified electrician. The subpanel should be maintained in accordance with the manufacturer's instructions. The manufacturer's instructions provide detailed information on the proper operation and maintenance of the panel board. Following the manufacturer's instructions will help to ensure that the panel board operates safely and reliably. When working on or near a subpanel, it is important to take appropriate safety precautions. Firstly, always de-energize the panel board before working on it. This can be done by turning off the main disconnect. Secondly, use appropriate personal protective equipment, such as safety glasses and insulated gloves. Thirdly, be aware of the potential hazards of electricity and take steps to avoid them. The requirement for a main disconnect at the subpanel with more than 6 circuit breakers is an important safety measure that helps to protect people and property from electrical hazards. By following the NEC guidelines and taking appropriate safety precautions, it is possible to ensure that a subpanel operates safely and reliably.